Hello everyone, and welcome to today's comprehensive guide on slurry pumps. Whether you're a seasoned engineer or new to the field, understanding the differences between horizontal and submersible slurry pumps is crucial for any industrial operation. I'm David, and with over 15 years in the industry, I'll walk you through everything you need to know to make the right choice for your facility. Before we dive deep into the specifics, let me tell you what we'll cover today. We'll explore both pump types in detail, compare their applications, discuss installation and maintenance requirements, analyze costs, and look at real-world examples where these pumps have made a significant difference. Let's start with horizontal slurry pumps, the true workhorses of our industry. Picture a robust pump mounted on a solid baseplate, its horizontal shaft aligned perfectly with its drive system. These pumps are built to handle the toughest jobs in mining, mineral processing, and power generation. What makes them special? Well, it's their heavy-duty construction and clever design features. The large impeller handles solid particles with ease, while the external bearing assembly makes maintenance a breeze. You can get them in various materials, from high chrome iron for extreme wear resistance to rubber-lined versions for corrosive applications. Think of a horizontal slurry pump as a reliable pickup truck. It's sturdy, dependable, and can handle heavy loads day after day. In mining process circuits or mineral processing plants, these pumps keep material flowing consistently, which is crucial for maintaining production targets. Now, let's switch gears and talk about submersible slurry pumps. These are the specialists of the pumping world. Imagine a self-contained unit that operates while completely submerged in the liquid it's pumping. Clever, right? These pumps combine the motor and pump into one compact package, with sophisticated cooling systems to keep everything running smoothly underwater. They're particularly brilliant for applications like sump drainage, dredging, and construction site dewatering. When it comes to choosing between the two, it's not about which pump is better, it's about which pump is right for your specific needs. Let me break this down with some practical comparisons. Think about efficiency. Horizontal pumps typically win in continuous operation scenarios. They're like marathon runners, designed for the long haul. Submersible pumps might have slightly lower efficiency, but they make up for it with their incredible installation flexibility. You can literally drop them where you need them. Speaking of installation, here's where things get interesting. Horizontal pumps need their space. They're like that colleague who needs a big desk to work effectively. You'll need a proper concrete foundation, precise alignment, and carefully supported piping. Submersible pumps, on the other hand, are more like that flexible team member who can work from anywhere. They need minimal installation space, though they do require proper guide rail systems and power cable support. Maintenance is another crucial factor to consider. With horizontal pumps, everything is right there in front of you, easy to access, inspect, and maintain. Regular tasks like bearing lubrication or seal replacement are straightforward. Submersible pumps require a different approach. While they might need less frequent maintenance, when they do need attention, you'll usually need to pull the entire unit out of the liquid. Let's talk money, because at the end of the day, cost is a major factor in any decision. Horizontal pumps typically have a lower unit cost but higher installation expenses. Think of it like buying a house. The purchase price is just the beginning. You need to factor in the foundation, the utilities, everything. Submersible pumps might cost more upfront, but their installation is usually simpler and less expensive. Now, let me share some real-world examples that bring all this together. In Australia, a mining operation faced a challenge with high-volume tailings transport. They initially considered submersible pumps for their space-saving benefits but ultimately chose horizontal pumps due to the continuous high-volume requirements. The result? A 15% increase in processing efficiency. In Germany, a major construction project needed reliable dewatering solutions. The tight space and temporary nature of the work made submersible pumps the perfect choice. They could be easily relocated as the project progressed, saving both time and money. Finally, let's look at an industrial processing plant in Canada. They faced a unique challenge. They needed pumps that could handle both regular slurry and occasional heavy solids. Their solution? A hybrid approach, using horizontal pumps for their main process lines and submersible pumps for sumps and emergency handling. This combination provided the best of both worlds. As we wrap up, remember this: the best pump choice depends on your specific needs. Consider your application, space constraints, maintenance capabilities, and budget. Don't just follow what others are doing, analyze your requirements and choose accordingly. Thank you for staying with me through this comprehensive guide. If you found this information helpful, don't forget to like and subscribe for more industrial equipment insights.